In this notebook we will learn how to handle a digital elevation model in Python. A digital elevation model, DEM, is a digital representation of the Earth's surface that provides information about the elevation or height of terrain features. It is typically a gridded dataset where each grid cell contains a value representing the elevation at that location above or below a reference point, such as sea level. DEMs are generally produced with LiDAR, light detection and ranging, or photogrammetry. Photogrammetry DEMs are used to create topographic maps, analyze terrain characteristics, simulate water flow, and aid in 3D modeling, among other purposes. But first of all, let's explain what is the differences between DTM, DEM and DSM. A DEM, digital elevation model, is a representation of the bare ground, bare earth, topographic surface of the earth excluding trees, buildings, and any other surface objects. A DTM, digital terrain model, is sometimes referred as a DEM. In other definitions it augments a DEM, by including vector features of the natural terrain, such as rivers and ridges. A DSM, digital surface model, captures both the natural and built artificial features of the environment, as shown below. Let's import all the libraries needed for this notebook. I've already prepared a DEM offline from the NASA's Earth Observing System Data and Information System. It has a global resolution of 30 meters, that is, each pixel will cover an area of that size. Let's plot the digital elevation model. The plotted rasters represent with a different color the elevation for each pixel. On the right the color map shows the elevation values. Let's plot the minimum and maximum values. In the next cell we can create a histogram of the values of our DEM. To do that we need to flatten the raster that is transformed from a 2D array to a 1D array. In the next cell we're going to see how to create a hillshade plot. A hillshade is a 3D representation of a surface. Hillshades are generally rendered in grayscale. The darker and lighter colors represent the shadows and highlights that you would visually expect to see in a terrain model. Hillshades are often used as an underlay in a map, to make the data appear more three-dimensional and thus visually interesting. To create such plot we have to create a light source object that represents the illumination point of the scene. Two values can be passed: the azimuth angle and the elevation of our light source. Before plotting we have to pass the raster to the hillshade method that will calculate the shaded raster with a scale from 0 to 1. If you prefer to have the DEM values in the plot bar you can pass the original raster to the plot bar method. In the next cell we're going to see how to create 3D plots of the DEM. We need to import some sub-modules from matplotlib and mpl_toolkits.mplot3d that provides some basic 3D plotting. In order to create a 3D plot we need to create mesh grid from raster bounds. The contour3d function in the next cell receives three 2D vectors, x, y, and z coordinates. View_init sets the elevation and azimuth of the axis in degrees. We're now going to see how to generate an interactive plot. For that we will use the plotlygraph_objects method. Since this plot is quite demanding in terms of resources, I'll limit the plot to a small subregion of 1000 by 1000 pixels. In this lesson we have learnt what is the difference between a DEM, DTM and DSM and how to work with DEM data in Python. If you have enjoyed this video, I invite you to subscribe to this channel. See you soon with more videos coming.